Hello. So in this video, I want to tell you a little bit about linear regression. But before that, I want to take a step back and talk about what it means to do machine learning in general. And so in the world of big data, where we have so much data that's available, what happens is that you often know a lot of information, but there's also a lot of information that you don't know or that you're trying to infer based on the information that you do know. And so sometimes what we do is we break that down into, inputs and outputs. Inputs being the stuff we know, outputs being the stuff that we don't know. And so let's say we have, inputs, um, and this is just stuff we know, and outputs being stuff that we don't know, and machine learning being a tool that we create to help us infer those outputs from the inputs. So this is like machine learning. That's effectively what it is. But can we see some examples? So let's look at a couple of examples. Let's say that you're trying to forecast pollution. Pollution has been increasing due to, let's say, the Industrial Revolution and due to like industrial plants and that kind of thing. So let's say that the pollution has been increasing drastically, and we've collected data samples. This is actually a real example. It's available online, but I think if you like go back to, let's say, like 1950 or something like that. I'm making up this number, but 1950, and then let's say there is 2020, and between this, let's say we've measured the PM 2.5 levels of pollution. So PM 2.5 is just an air pollutant, and let's say we've measured the amount of pollution in the air. So this is pollution, and let's say there was, not that much pollution in 1950. Maybe a couple years later, it was much more and much more. Maybe it dipped a little bit, and then it sort of scattered around. Um, and eventually we reached to 2020, right? So that's approximately where 2020 is. And as you can see, what seems to be happening to the pollution as we go through time? As we go forward in time, what happens is that the pollution seems to be increasing. And not only that, it seems to be increasing kind of proportional to how much the time is increasing. And so what I mean by that in more technical terms is that it looks linear, like a line could be put through this data and still make some sort of sense. And so what we can do here is, let's say we eyeball this and we go through with a line and we put this through the data. It might not be that great, but let's say we eyeball it. Um, and what happens now is that this line itself doesn't actually go through that many points, but it does go close to a lot of the points. And that's what's important. It sort of gives us a model for, let's say, we want to go to like 2010, and we want to know what was the PM 2.5 level or like the pollutant level in 2010. We can use this line, whatever the point is on this line, and go to that point and then see, oh, okay, this is the level at that time. And that might not be the correct level, but it will give us a model of, what it could be. And why is this useful? Why not use the real, like the actual sample data, you might be asking. So the thing that this allows us to do that looking at the original data did not allow us to do was go beyond 2020. Let's say we only have data till 2020, but we want to go beyond 2020 to approximately like 2030. I'm gonna put a this is not to scale at all, as you can see, but let's say we want to go to 2030 and we want to see um, over there what is the pollution. And what we can do is we can draw a line like this and we can find out at what point um, this like line is at 2030. So what is the level of that line at 2030? And that'll give us a prediction for the pollution levels at that time. So this is all well and good, but how do we go about doing this? And so that is the whole idea of linear regression. And I'd like to pause right now because I'm going a little bit over time, and I'll see you in the next video.